So we're going to talk right now about the technology guide in our textbook, and for those of you that have not seen that yet, I just want to pull up the ebook on my screen here, which you can see that I have our textbook for this class loaded up. And now some of you guys are starting to figure out when I do these Kahoots in class that I'm pulling some of the terminology right from the words that they have at the end of the chapter, like the words that you should learn. So I'm kind of giving you that heads up. So those are things that might end up on a quiz or an exam, because some of the terminology, frankly, is important. And if you look at one of the objectives of this course is to understand how to apply that terminology properly, because nothing will weed you out of an IT job faster than you not knowing what you're talking about. Can you believe it? That guy said ROM when he really meant RAM. Now, for as dumb as that sounds, that's how computer geeks are, right? But if you can speak intelligently about something, even if you're not an expert, it really kind of changes things. All right, but the technology guides are at the end of the book, and the first one that we're looking at is the one about hardware. And hardware really relates to the physical aspects of information technology. And when we say the phrase information technology, we do mean the hardware. And if you guys haven't figured out yet, information systems are about the information that goes through these devices, not about the hardware. So when you hear somebody say information systems, it's not hardware related. Information technology is hardware related. But when we think about computers, now you guys are all so young, with the exception of a couple of gray hairs in here, that you were born and computers were just there. Right? And kind of it was that way for me too. I mean, computers existed when I was born, but it was not something that people had in their household, or even dreamt of having in their household, or the only people that could afford computer systems back then, so you have to guess what decade I was born too, right, would be the government, the military, big businesses, big educational institutions, and evil masterminds, right? I kid about that, but that's the reality of it. But computers haven't been around that long, especially electronic computers haven't been around that long, because heck, how long has electricity been around? Kind of looping back to that whole. Yeah.
10 years.
It's only been around 10 years? Prior to that, we had to get on our bikes and charge our batteries for our phones, right? Yeah. Electricity's been around, actually, some people will argue it's been around since ancient times, because they are finding proof that ancient peoples were building batteries to do things like electrolysis and things like that. So we really don't know how long the manipulation of electricity has really been around. But in terms of modern society, it really has only been around since the late 1800s for public consumption. Where was the first place on the planet where people could get electrical service? Here in the States, right? In New York, thanks to people like Thomas Edison and Tesla, right? They had competing technologies. One used alternating current, which is what we use now. That was Tesla's technology. And Edison's technology was direct current, like what we get out of a battery. Much more dangerous when it's powerful, like it's really strong. And that AC ultimately won out. So that really kind of enabled a lot of things to happen in society. A lot of things. But the concept of computing really kind of goes back a whole lot farther. Now, I don't have like a slideshow on this. I usually kind of do it off the cuff like this. What is the very first computer? And I'm typing it in really slow.
Atari. No.
Yeah, Atari. But you guys are not thinking like me, right? Yeah, it's the Abacus. So now you guys can Google this all you want. But what the heck is an abacus? If you guys,
It's a calculator.
all right, used for doing what? Math.
That nobody wants to do by
No, everybody loves to do math. You know when you love to do math? When the money works in your favor. Then you love to do it. Look at all that money I'm making.
doing other people's taxes.
But ballpark, when do you think this device was invented? No, this is a Chinese device.
Oh, they're
Yeah.
long 1408.
1408.
Who Googled it?
Yeah, somebody Google it. When was the abacus invented? I think you will be shocked.
During the Han era.
Are you just dropping that stuff?
Nobody's
Yeah,
Googling.
500 BC.
Oh, Google.
That's all it says?
It says 500 BC. You're invented.
500 BC.
Well,
2,500 years ago, folks.
Babylonian.
Somebody said, you know what? Hey, I'm counting all my sheep. For every sheep, I'll collect a rock, you know? And that's maybe how they did it. And then after a while, they figured out, well, what if we just make this thing? And I don't know if you guys ever learned how to use one. When I was in school, we learned about like different number systems. And those different number systems are built around the fact that we usually have like 5 fingers on a hand, right? And that's kind of how that works. If you look at an abacus, there's 5 beads on the bottom and then 2 beads up top, right? So if you add up 5, then you move the top bead over, you start at 0 again, add another 5, both beads are up, you got 10, right? And then you can use it. And I've seen people at trade shows. This is really kind of strange because when I was a kid, my dad was, you know, into import-export. And he'd go to all these trade shows. He'd import stuff and he'd wholesale it out. And he thought, you know, what would be really good for you, son, is to come with me to the trade show and, you know, hang out, you know. And I did. And I did learn a lot. And what really impressed me is we'd always do this show at McCormick Place in Chicago, and the guy right across the aisle from us was this Chinese guy, right? And he would sell, you know, Chinese wares, you know. And when somebody gave him an order on site, all the normal people would write up the order, got all these numbers there, they pull out their calculator, and then they add it all up and they give you a total. This guy did it with an abacus. And you know what? He did it a whole lot faster than anybody with a calculator because he knew how to, it was like, and he had an answer. And what this is, for as primitive as the device is, it is a mechanical computer. Because he could do math, he could multiply if you know how to use the thing, and it stores the information too. Better than like carving a notch in your stick or collecting rocks or, you know, writing on the cave wall. This is kind of like the step up. But this is a revolution, and what's fascinating is there's people that still use them. Now, I don't know how it is in China now. I'm gathering that most people don't carry an abacus in their back pocket, but they probably have a scientific calculator when they're in school.
Yeah.
But I would bet in China they still teach people how to use it.
It's still used today right now.
Yeah, absolutely. Absolutely. Just like you can use your, you know, the math you supposedly learned in school to do the math that you need to do, right? Now, my dad, conversely, he refused to use a calculator because he grew up in the marketplace in Greece where my grandfather would sell fish, bring it back on the boat, they'd take it to the market to sell the fish. And if you can picture, like when you go to like a deli, and you say, hey, I want 3 pounds of that, you know, turkey, right? And they put it up there, they type in the price, it multiplies the weight times the price and gives you the total. Well, he didn't have those devices. So he'd have to take a fish, throw it up on a scale and go, oh, that's like, you know, 1.2 kilos or whatever. And, you know, Dad said I should sell this for 20 drachmas a kilo or, you know, whatever the price was. And he'd have to do the math in his head, right? Or on a piece of paper. So that's how he grew up. And then he can take a whole column of numbers, and before I could even type in the first 2 or 3 numbers, he'd have the whole thing calculated. Because they did like such heavy drill and practice in their brains to like what that all adds up to, and he had all these little shortcuts he did. I didn't understand what it was, but he could just plow through the numbers that fast. So maybe the best computer is really in our heads. You know what? Truth is, what we're trying to do with this technology is to model what happens here to some degree, hopefully without all the flakiness. Right? All right, but from here, society moved forward. We had different number systems, right? We had the Roman numerals. You guys learned those, right? Those were really kind of weird. In fact, they still like number the Super Bowls that way.
Yeah.
You know, if the 1 or the I comes before the X, it's a 9. You know, it's like, it didn't make any sense. So then they came up with the base 10 number system. Who invented the base 10 number system? I think a lot of people forget this. Yeah, Arabic people. They're Arabic numerals, right? So that they came up with the numbers 1 through 10, and it's a number system that we use currently. And everything is kind of based around that. So I think that's fascinating to remember. So the Arabic peoples, when the Western world went through this like historical decline, right? We had the Roman Empire and the Greeks and all that, and then all these barbarians started to invade Rome and kind of destroyed the empire. And a lot of the stuff that the Western world had developed got destroyed. The libraries, a lot of the written records were burned. Who kept all the records? The Arabic people kept all the records, right? They didn't get destroyed. Rome did. Constantinople got destroyed, many times over. So the Arabic peoples held on to a lot of the knowledge through what we call the Dark Ages. And as Europe started to rise out of the Dark Ages, they started to kind of rediscover a lot of this stuff. So they took on the Arabic number system. They finally had alphabets to read and write with. And then the other thing that happened is they started to mechanize, right? And the way that people first started to mechanize in society was they used the power sources that they had available. They didn't have electricity, but yet they had mills and they had power tools. You know how they powered them? With water power, with the wheel, right? So you'd set up a mill, get the big wheel spinning, and then you could just, this thing is spinning, you just attach stuff to it. So it's a grinding wheel, a saw, a drill, a loom, whatever. And what happened is we had this guy that got really smart. And he said, I'm a rug maker, right? And I make these beautiful rugs on my loom. And you know what? The King of France has noticed that I make these beautiful rugs. And he wants some. He goes, I love that rug. Can I have 100 of them for my palace, please? And the guy's like, oh, darn. One rug took me 3 months to make all by myself. How am I going to make it go faster and get other people to help me so I can make 100 of these? So he figured out a way to hook up his loom to the mill, right? So that it would, I don't know if you guys have ever seen a loom.
Yeah.
Basically, there are devices like this, and these are real primitive ones. But basically, the way it works is you have these threads and they intertwine, right? And then you send a colored thread through, and then you switch the levers and they go like this, and you put another thread through, and it just keeps going, and you make a pattern. Now, the problem was he figured out how to mechanize it, but now he's like, well, how do I make the pattern repeat? So what he did is he did this. Let me see if I remember. Let's see. It's reading my mind. That's what Google's doing. Is they came up with this, which is the Jacquard Loom. And what I want to do is kind of zoom in on that a little bit and show you this device. So this is, a model of one of the looms. But if you can look really close, in fact, let me see how much of a zoom. Yeah, see, I zoom and it doesn't really get bigger.
Hold on the plate.
Yeah. You know what those are? Those are wooden cards, and then they would punch holes into the cards to represent which color thread should go through during each pass through the loom. So what the guy did is he would take those and he would string them all together in a sequence. So he might have hundreds or thousands of these punched in. And that way he was programming his loom. You listen to the words here, programming. He's telling the machine what to do in a sequence of steps. That's exactly what computer programming is, you guys. It's exactly that. So what he figured out how to do is take a mechanical process, turn it into mass production, and be able to replicate his designs, cutting the production time down to a matter of minutes, and could fill that order. Okay, so how does this tie into computers? Well, storing a set of instructions is where the tie-in is. Okay, so now we have all these other brilliant people. There's these people named like Charles Babbage, right? And he came up with this thought, and I'm not really sure even his timeline exactly. We could probably look it up. This is his picture. But you notice the words that come up here, right? What he came up with was this thought that, well, if he can program that thing to make a rug, maybe we can take a machine and have it do math. I mean, we got an abacus, right? Why couldn't we take a machine and then give it a really complicated set of instructions that we can't really do on paper, but the machine could do, and because it's a machine, it won't even make a mistake, right? It won't forget to carry the one or something like that. So he had this plan to build this thing called the analytic engine. And he drew up blueprints for it and all this stuff. He never got to the point where he actually built it, right? But what he did do is he shared those ideas with a few people. And here's one of the people that he shared it with, Ada Lovelace. Now, sorry guys, the first computer programmer was not a guy. It was a girl. Ada Lovelace wrote the first computer program that was designed for that machine that never was built. So she looked at his designs, figured out how it worked, and then she figured out what kind of instructions should go to the machine to make it actually do the math. And believe it or not, those instructions, and there was an article not more than 3 or 4 months ago, that original computer program she wrote was like on a piece of paper, I think auctioned for like $250,000, because it was the very first computer program, hypothetically. But it was for a mechanical computing device, which I think is fascinating if you think about it in that context. Now, at the same time, now we're kind of fast forwarding into the early 1800s now, when Ada Lovelace did this. And it was maybe, I'm guessing like 1830 something. You guys can Google it. And
1815, so yeah.
okay, well, ballpark, right? And so we had a few people actually trying to build this engine, a lot of different attempts at it. Eventually they actually did build a working model, I think, well into the 20th century, to prove that the concept was sound. But people took those ideas and married them with other technologies. So what was happening in the mid-1800s that was also very revolutionary? Did you guys ever hear of a device called a telegraph?
Yeah.
Right. A telegraph, right? And we'll probably talk about this device again because it's pretty important. Is this really weird little device? All you need is 2 copper wires, a power source, and one of these little capper things on either end. And basically what you would do is you walk up to this, and you just tap that button, and it just sends a click over the line to the other end. And you guys ever heard of Morse Code?
Yeah.
Right?
Certain kind of things.
Yeah. Like when we were kids, Morse Code was still a thing, and we would play games where we'd go, what's that?
SOS.
SOS. See, the old guy knows it. Plus you were military, so you had to know that one, right? But you know the alphabet and you tap out messages. But what that device gave us that was so revolutionary was all of a sudden, if I could string copper wires from one town to another, I don't have to write a letter and give it to a guy on a horse that might get like robbed or attacked by Indians or fall off, a cliff or get sick or whatever, because he used to have the Pony Express. You'd give the guy a letter in like Denver and then he'd ride it all the way to California like 3 days later. And that's if everything went okay, right? Now you got wires hooked up, you have instantaneous communications from one spot to another. That's revolutionary, folks. And the first transatlantic telegraph lines, I think, crossed the ocean in the mid-1850s or right around that time. Pretty fascinating. Okay, so how does that tie into computers? Well, this is the dawn of networking. The analytic engine is the dawn of computing. So, step forward a little more in time, late 1800s. United States is a place where a lot of people are immigrating to from all over the place, right? They hear there's gold, they hear there's jobs, there's free land. And so we had this huge explosion of population moving westward through the country. Lots of people coming in. But we had this thing in the Constitution that said, you know what? Every 10 years, we need to go out and count every man, woman, and child. It's called a census, right? And they had these people that do that job. And they still have those people that do that job, although now mostly they just look at the voter registration, but separate story. So what they would do is every 10 years, they'd leave Washington, D.C., travel to the far corners of the United States and all of its territories and possessions, and literally walk up to every house and go, hello, how many people you got here? Okay, thanks. 1 man, 2 women, 3 children, 4 goats, whatever. And they would take the census, they would take all that data then, get back on their horse or train or buggy or whatever they had, go back to Washington, D.C., and fill out the reports and, report to Congress. Now, those numbers are important because they would count population, right? So they would know how to, set up, senatorial districts and representative districts and all that kind of stuff, and how the money was allocated from the federal government was based upon those numbers, and it still is, right? Now, the problem they had is the population was growing so fast and their technology was so old-fashioned that by the time they collected the data, it was already time to start again. So they were running out of time, so they needed to figure out a way, how are we going to do this faster? So what they came up with is they stole the idea from Jacquard and his loom, where they could take the data and represent it by punching little holes in a cardboard card and then feed it into a machine invented by a guy named Herman Hollerith, where they would take the punch cards, put it in the machine, and they would crank it through the machine, and the machine would mechanically add the totals in all the categories, and then at the end, output another punch card. So really important concepts here is that device, in fact, here. Yeah, these are all basically the same device, but this device here was invented by Herman Hollerith that they used, I think, in the 1890 census the first time. The company that he founded that built this machine became IBM. And that company is still around, folks. Right? So it was a mechanical adding device. So the key things are mechanical computer, punch cards to store information, the machine processes the information and outputs more information. So think about that, right? There's this process. I might even write on the board if I have a marker, and I guess I'm not going to. But the concept is that we have information that we gather. That's an input. We process that data. In this case, we just add and put it in columns. And then we output more information. Sometimes the output of an information system is more information. But the information that's output is the totals, right? So then somebody can look at the report and go, aha, there's only 3 people in Alaska, right? All right, so from there, they kept improving on these designs, right? So if you look at kind of a revolutionary thing in the 20th century, yeah, accountants and cash registers in the early 20th century were mechanical adding devices just like this. Sometimes they had like paper tape. So instead of their output going to a punch card, it would just print out on this little roll of paper. When I used to go to the grocery store as a kid, we had a Kohl's food store right by our house. And I'd go in there, and they had a cash register, I swear to God, looked very much like that. Just like it was like a big wooden box.
Looks like a tape, like one of those label makers.
Yeah, it kind of is, actually, right? So the lady would have to like click, 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 ding, click, click, click. So if you had like a big order, man, they got to work up. But it was a mechanical adding machine, is what it was. And it wasn't well into the 70s, even into the 80s in some of their food stores, before those things went away. And got to the point where they were electronic devices, mechanical adding machines. So, have you guys ever seen the movie Imitation Game? Nobody? Okay, well, I'm going to pull that up on screen too. You know what? If we had time, I would actually watch it in class. But this is one with that dude. Yeah, thank you very much. Dr. Strange. Yeah. Yeah, that's exactly what it is. Yeah. So during World War II, the Germans were aggressively pursuing computing technology because they were aggressively pursuing a lot of different things. They had jet planes, rockets, things that nobody else had. And the way they were able to get there was because of the advancements they had in their electromechanical computing devices. So they had these really fancy adding machines that could do real big math equations to solve the trajectory of a rocket launch. You know, that kind of thing. It takes pretty advanced math. And the slide rule doesn't cut it because you have to be really precise, right? So they started using these mechanical computers. They also started encrypting all of their communications. So during World War II, they had this thing called the Enigma Machine. Did you ever hear of that?
Yeah.
How many of you have been to the Museum of Science and Industry in Chicago? Not the movie, just the machine. If you go to a museum in Chicago and you go visit the submarine that they captured from the Germans, they had one of these devices on it. It kind of looks like a typewriter. And what the Germans would do is they would type their messages into the machine, and then it would code it, and then they would send the coded message out over the wires. Anybody could intercept it. So the British were constantly intercepting it, and then eventually, took them a long time to figure it out, but eventually they built a computer to decode it. You know, once again, electromechanical, so it was part machine, part electronic, but they were able to finally crack it. You know how they cracked it? Because the Germans every day would change the code at midnight or 6 a.m. or something weird like that. But for whatever reason, they were dumb enough that every time they would start the new day, they would go Heil Hitler. And eventually the British figured out, wow, they start every day with that, so we got all these letters figured out already. See like the trick? So eventually they cracked the machine, but had to keep it secret. So, and what they did is they would use the information to kind of very strategically, you know, block, you know, certain actions and kind of turn the fate of the war. In fact, they credit that computer with really turning the tide of the war so that the Allies won. Otherwise, we'd all be speaking German right now. And we'd all be a lot more disciplined, probably. Yeah, so it's a really cool movie to see. You know, it's got other storylines too, but that's kind of the main crux of it. So the Americans, when the war ended, you know, and the Allies started going in and taking over all the German stuff, they were looking at what the Germans were building going, how do these guys make rockets? How do they make jets? Holy cow, it's a good thing, you know, we beat these guys because otherwise we'd be in trouble. It's like, hey, these guys are really smart. Maybe we should bring those scientists here. Right, and that's exactly what they did. Everybody rushed in, the Russians, the British, the Americans, and took all their top talent and brought them here. And what did we make them do? Yeah, we had them build nukes and computers and missiles and all sorts of like dastardly things. So like, what drives computer technology? Blowing things up, right? And what the Americans built that was unique was this. And I promise we'll take a break in just a moment. Yeah. There's this device here called Eniac. And what's fascinating about this device, and you can see all the images, you can Google it yourself, is Eniac was basically the world's first fully electronic, fully programmable computer. No mechanical components. No punch cards. All of it was wires, vacuum tubes, switches, and lights. So if you were to program the machine, you'd be like plugging cords in, and flipping a couple switches, and then hopefully you did it right, and you hit a button, and then some other lights would turn on. And then you'd have to like decode that, you know. But the reason they built the machine was to, once again, help do really advanced, you know, highly advanced trigonometric functions so that they could figure out how to launch rockets and get the right trajectory, and how to, you know, figure out like whatever it takes to blow things up with atomic weapons. Now this wasn't actually in service until 1946. The war was over, right? But we had other things that were going on, like the Cold War and whatever. But this turned the tide and kind of put Americans at the forefront of computing technology as well. That computer system is no more powerful than like a $2 handheld calculator from the dollar store, right? They had to have 5 central air conditioning units cooling the room because there were so many vacuum tubes that otherwise it was like an oven in there.
Yeah.
Another really great piece of computer history, you guys ever hear of like there's a bug in the system? You guys ever hear that? Yeah. But they had a problem one day. The program wouldn't run, and he started ripping stuff apart and looking, and they found like on one of the tube sockets there was a bug shorting out a connection. So they debugged the program. All right, take a break, you guys. 5 minutes. All right, now we're going to take a look at the technology guide, and we're taking a look at the very first one in your book, and it starts, I think, on page like 408 or 409. And I'm going to be interspersing these technology guides throughout the semester, and we start with hardware. Now, we were already talking about hardware a little bit, and you know whether or not you're very familiar with hardware, you're going to have to learn at least some basics before you get into this field. So like if you're a web or software person, truth is you kind of don't care about how a computer operates as long as it operates and does the stuff you want it to. And that's how like most consumers think about it, right? Man, this damn thing doesn't work, you know, throw it out, get a new one, right? But understanding what a computer does and what its components are, and then also making a comparison between hardware and how software works is kind of interesting. So remember I was telling you how the IBM guy, when he did his punch card thing, he would take that information and he would input it into the machine, and then it would do some processing, and then it would output more information. That concept of input, processing, output extends all the way through all information systems, and in fact, even extends beyond information systems into regular systems theory. So if you could actually think about like how a factory works. Like a factory might take like raw materials, like a log, and bring it in, mush it all up, turn it into a piece of paper. The process of turning it into paper is the process, and the output is the paper. So input, log, process, mush it up, make it flat, make it white, whatever. Output, paper. So input, processing, output, right? So when we work with technology and we write a computer program, that's what we teach our programming students right off the bat. You have certain inputs, right? You process those inputs and you create output. The output might go to a printer or the output might go to your screen. But either way, think of a video game. Your input, moving your mouse, your joystick, you know, whatever, clicking, you know, WASD, whatever, right? Gamers know what I'm talking about, right? Right? Those are your inputs. Something's happening in the background. It's all processing, whether it's multiplayer or single player or whatever. And the output is what you're seeing on the screen. And hopefully the output is, I got the guy before he got me, right? So that concept extends. So let's kind of scroll down a couple of slides here. So I'm going to go right to this slide here. It's the 5th slide. So when we think of computers, we tend to think of computers either as these boxes that are on our desk, right? So there's a box, there's a keyboard, there's a monitor, and a mouse. Maybe some speakers or other stuff, but that's kind of it, right? If you think of it on a laptop, it's all the same stuff, it's just all in one piece, right? But isn't a phone and a tablet also that?
Yeah.
I mean, I don't have a keyboard, but, well, yeah, I do.
Yeah.
Better yet, I can just talk to it.
Yeah.
You can do that on a computer too. All right, but we have these things that fall into these categories. So every computer system that we think of as a computer system has all of these things. We have a central processing unit, aka CPU. The CPU is not the box. The CPU is a chip, right? You guys know what a CPU looks like?
Yeah.
Some of you don't. I'll show you. And you guys should do this, right? CPU. Like you guys don't know how to, right? And that's what they look like these days. But basically, they're these little things, and I swear to God, they're only like this big. And they're loaded up with billions, and that's not an exaggeration, billions and billions of transistors. Right?
Open and close Telegraph.
Yes. And it's the heart of the computer system. It's where all the processing, right? We have input, output, processing. You guys are going to see on a computer system it's the same way. How do you input information into a computer system? I hear somebody clacking away. Yeah, keyboard. Right, voice. Anybody use biometrics to unlock their phone?
Yep.
That's input too. I know, I do it. My wife says, why do you do that? That's crazy. And it's like, no, that's easy.
It is.
And it actually is better than typing in a pen each time. What about output on a computer system? What's output? Speakers? Yeah, whatever you see on the screen. Printed on paper?
USB.
Well, yeah, you could argue that I take the information that I'm outputting and I put it on storage, sure.
Or you put it in with stuff on it.
Or you can burn a disk, right? Absolutely. All right, so primary storage we already talked about, that's the RAM. The RAM in a computer system is the part that loads up whatever you're running. So the computer boots up and Windows loads. But where does Windows load from? Pulls it off the hard drive, so that's secondary storage, and loads it into active memory, or RAM. And all the work on a computer happens in RAM, in primary storage. A really good analogy that helped me understand it when I was first introduced to this was kind of the analogy of a desk. Okay? So like secondary storage might be your file cabinet with your files and folders. You go in there and you need to work on something, so you find the thing you need, you find the folder, pull out the documents you want, and then you put them into memory, RAM, primary storage, which is your desk. Bigger your desk, the more stuff you can work on at the same time. The more RAM you have, more stuff you can see all at once.
Doesn't that go along with a retail store, back in storage, shelves are RAM, cashiers are processors?
Yeah, I like that analogy too. All right, so that kind of thing. So we have all these different categories that are happening. Now what happens with computing technology in general? If it's appropriately used, you can use it, you can see, to actually make you more competitive if your competitors are not on board. So can you imagine if you're like in an industry where, let's say you have like a lawn mowing service, right? And you're like one of 5 in a town. Your lawn mowing service, everybody's got mobile devices, tablets, you got a website, you know, you're all hooked up. You might beat out your competitors who are bigger because they're not on board yet. And that's a really primitive example, but that happens quite a bit. The thing that's really huge these days is that last bullet here. And we're seeing this more and more. And for those of you in both the software program and the web program, we are already this type of program, BYOD, bring your own device. Now, we do have computers in the classroom, but I always recommend to IT students, right? You need a good laptop, probably a good desktop too, and a tablet and a phone, and a game system. Heck, you know, you're in it, you may as well be in it, right? That's kind of the way I see it. But the truth is, that movement is now starting to happen in what we call the enterprise. So big organizations now are changing all the rules. So like instead of like forcing you to use one of their corporate laptops that's all locked down, like I don't care if they bring their own. We just put them on a different network. Or maybe not. So there's different challenges there, but that's the thing that's really grown a lot, is a lot of corporations are allowing people to bring in their own devices. In terms of the types of computers out there, really, for most of us, the types of computers that we're going to encounter will fall into these categories. As consumers and regular end users, right, the people who use the technology to do work, we are in the client category. A microcomputer, that includes things like a desktop or a laptop. Okay? Obviously, tablets, laptops, wearable technology, yeah, like the watches, Google goggles, or you got a Fitbit, right? Heck, you know, kind of your phone kind of is too.
Yeah.
Really? But then we talk about servers, and servers are the horsepower machines. In fact, we have servers right across the hall. I'm going to take you on a tour of some of our facilities in the upcoming weeks. But we are looking at machines that have many, many processors, huge amounts of RAM, huge amounts of storage, incredible amounts of bandwidth, sometimes working in tandem, driving a lot of our applications, our websites, storing our data, really kind of making all the infrastructure we take for granted work. Right? Some of you will learn how to work with those platforms. So like if you are in the CSS program or the networking program, you guys learn about servers and stuff. Web and software, we interface with those systems, but we don't really learn how to manage them necessarily. With my background, I've done both. And I think, honestly, it never hurts to know a lot. It just makes you more knowledgeable about whatever you're doing. But big growth area. And one of the things that's changing up here in the server environment is the fact that a lot of our servers, which we used to just have like boxes and racks like we have across the hall, are now being pushed up to the cloud. So we're using other people's infrastructure to run our stuff. And it's a big change that's happening. So people that are in the networking program in particular, you're going to see your jobs becoming a lot more cloud-based. And that's going to be a big part of what you learn in the future and do in the future. All right, so microcomputers, we were talking about that. And you guys probably know all of these things except for thin clients. What's a thin client? He's one of my clients, he's not very fat.
It's a PC that can connect to the server or something.
Yeah, you're on the right idea. And in the old days, we would call thin clients typically what we call dumb terminals. They're machines that really, on their own, don't do a damn thing. Their only job is to connect to the mainframe or the server, and then what you see here is the screens. Right? You guys ever done VDI here on campus? Anybody? Okay, nobody yet, but you guys will, right? And that's basically what that is, right? A fat client is similar because you're doing the same thing, but you're using a regular computer system to do it. So most of our students, if they explore this field at all, will be through fat clients, usually through virtual desktops. Now that's kind of a weird thought right there. What do you mean, virtual desktop? Yeah, both the software and the web departments here, we have virtual desktop environments for our students. So like if you have a computer that's not powerful enough to run all your software, you don't have enough storage, you can just log in through the web to Gateway's virtual desktop environment and pull up a full Windows 10 environment, just like on these machines, with all the software you need already installed.
That's pretty cool.
Yeah. It is really cool, actually. Where it gets weird, right, is this concept that you're looking at something on your screen, but it's not really your computer.
Right.
And you know what? I do that at home. I run a piece of software called Teamviewer, where I have all my machines at home are up on that. So if I want to like connect to home and like, you know, do my legal downloading, she's typing that in, you know. To manage my files remotely, I can do that, right? And all I'm getting is a picture of that environment pushed to my screen.
Right.
And all I'm sending is mouse and keyboard movements, and what it's sending back is what's coming up on the screen. But I'm operating a computer somewhere else.
Right.
The weird thing is, so much of corporate America, when you step into an office environment, you sit at a computer, and it looks like you're using that computer, you're really not. Because there's so much of an advantage to a corporation to be able to centralize all those desktops, to be able to update them all at once or back them up all at once. They don't have to worry if like lightning strikes or a bomb drops or you lose your laptop, because it's all virtual. It's not on the machine. There's a lot of advantages. So that's a big thing for your guys' future too, right? Hey, look, devices, okay? All right, now, some of you guys, and I'm going to actually, I just want to give you a heads up on this. I'm going to be adding one more assignment to Unit 2. It's a really trivial one, but I'm going to ask you, what kind of technology do you already own? Right? I started like counting at home. and this is really scary, right? Because first of all, I'm an IT guy, right? So I started counting like, I got my Mac Mini, I got my server, I got my file server, I got my old workhorse PC that I really don't use for anything anymore, I got my Raspberry Pi, I got my old laptop, my other old laptop, 3 laptops, the Mac laptop too, plus the 2 that I have here. There's 5 laptops, that's just me, right? And so I'm just trying to think of all the devices on my network, you know? And then I started going, oh wait, my son's got a desktop, he's got an Xbox, PlayStation, you know, he's got 2 PlayStations, right? We got the Roku, we got our smart TV, he's got a phone, wait, he's got 3 tablets, and this stuff just like adds up over time. And I started like chronicling all the stuff we have in the house. We have like 40 internet connected devices in the house, somewhere in that range. It just blows my mind. So I'm going to ask you guys in that assignment, what kind of stuff do you own? I just want to kind of get like a gauge, because I'm noticing this trend that people have many, many different devices. Some people don't, right? And we talk about that one term from chapter 2, which is called the digital divide. What the heck is the digital divide?
People that don't want to be connected with you.
Yeah, and you want to actually check that, because that is correct. There are people, okay? And see, I'm in that age group where I have friends, right? They don't want to touch a computer. Because we grew up in an era where it's like, I don't trust that. Government spying on me. You know what? They're right. But we don't care because we can watch YouTube that way, right? You know? I mean, that's the truth of it, right? Is there's trade-offs, right? And I'm on the opposite end of the spectrum. I'm like, yeah, bring it, you know? I'll take all of it. And I hope you guys feel the same way, because you know what? It's an employable skill, guys, right? Because not everybody knows a lot about this stuff. So that's my challenge to you, is like, what kind of devices do you own? And I just kind of want to have a gauge. But the digital divide also extends to something else, economics, right? So it's like, man, how do you own all those computers? Somebody would ask me that about all the cars I own too, because I have 10 cars, right? And 4 motorcycles. But they just kind of accumulate over time, and I don't get rid of them. So like, my old laptop dies, or still kind of works, the battery's bad, the fan's not good, the case is cracked. But if I just like let it sit on a desk and run, I can save files to it, and I can walk up and play solitaire, or
Linux.
this is the porn machine, right? No, I'm kidding. You guys don't do that, right?
Yeah.
But
That's what track phones are for.
that sounds like an expensive habit on a track phone. All right, but that's the reality of it is. So I just kind of keep my old stuff, right? And then when I need a new machine, I go out and buy one. And plus, school gives me stuff. But there's people that can't afford to, to feed their kids and pay rent. High-speed internet and a laptop really isn't a priority. I'm sorry, it just isn't. But that creates a huge problem. You know what the problem is all the work of the future is going to require knowledge of these machines. So as a country, we have to strive really hard to make sure that even our kids, and they're doing it now, and you guys are kind of a product of it, you get immersed in technology while you're in school. Milwaukee Public Schools, where my son goes, my daughter goes, they give them Chromebooks.
Yeah, that's what my school
And they give them internet.
My school did that too.
We don't qualify, but we don't qualify for the internet thing because I actually have a job. But there's a lot of people that don't. They have, they come from families where it's single-parent households or foster homes or whatever. And MPS is realizing if we don't give these kids the technology and the connectivity, how are they going to go out and get a job and compete with somebody, comes from the suburbs and their parents have a boatload of money and they have, the Xbox, the PlayStation, the laptop, the tablet, the desktop, the gaming machine, and like 20 other devices too. How do you compete with that? Right? So it's really important, you guys, that everybody's computer literate these days, as much as it is to be anything else literate. Okay? And I'm trying to keep an eye on the clock here. Let's go to input and output, right? We talked a little bit about this. Input and output technologies. So let's kind of rifle through these kind of quick. All right. So here's the kind of list and stuff that's kind of a little odd, but if you go to the next slide, you can see the normal stuff, right? Stuff that you would use to do input on a computer, keyboard, mouse, different types of mice. You know, I have like this school laptop here. You guys have seen touchpads, right? But have any of you ever seen a touch stick? You see a little thing that's right in the middle of the keyboard here? It's kind of hard to see. That used to be my favorite laptop pointing device. I was thrilled when I saw it on this machine because it's right in the middle of the keyboard. So if like you reach your finger to move the mouse, your home row typing, you left-handed or right-handed, you just move a little bit to get to the mouse. You don't have to like lift your hand and go to the touchpad. So when touchpads became popular, I was like, what the heck is this? Right? Which, I mean, I can use any kind of pointing device, doesn't really matter, but I still prefer a regular mouse. That's just me. Okay, but a lot of different types of input devices, but they have these like weird ones, right? That they're trying to, you know, human data entry devices. I guess a joystick is one, a touch screen. Now this school machine's not touch screen, but how many of you have touch screen laptops? Right? Do you use the touch screen feature a lot?
No, not really.
What'd you say? Yeah, there you go. Because my wife's got one like that now too. Yeah, I find myself not using it that much.
Use it to like play Magic together.
Yeah, I was going to say like Mahjong or Solitaire. It can be useful, and I always kind of forget at times that I have touchscreen, but not on this
I've seen this
device.
one, I think HP came out with a new like kind of laptop where they put a digital screen by the pad, and you can like access the digital screen while you're still using the laptop at the same time. Sort of weird, like.
It's almost like a Wii U or something, right?
Right?
Right? I mean, right. But different types of input devices. Voice recognition is pretty huge, right? It's like one of the classic things in computer science is, you know, like you recognize get the computer to recognize your voice, and you can say, "Okay, computer," you know. I think of like Star Trek, right? You know, plot the course of the next star system, engage, you know? And the computer just does it. And now, you know, we just, you know, for a while, Google had this, and you know what? Did you guys ever use the search by voice thing?
Yeah.
All right, nobody talk, all right? What should I search? Oh, I know. Star Trek Discovery. All right, so I've been watching this. This is a great show. Right. You guys wouldn't have guessed I'm a Trekkie, but I am. And I use this as the classic example of voice. You guys caught how I did that, right? I just clicked the microphone. You guys do it on your phone all the time, right?
Yeah.
But for a while, Google had it, so if you went to Google and you said, "Okay, Google," it would just turn on and do it. So what does that mean?
Always listening.
It's always listening. Or, yeah, right, exactly, or Siri, or whatever device you have, they all have their own name. But that's a huge thing, and it's going to get to the point where I see people already, right? You ever text with your friends, and you can tell when they use the voice to do it?
Yeah.
Yeah, we can catch up with typing.
You know, what I think is really funny is sometimes I do the voice thing, you know, I'm like, "Okay, honey, what's for dinner? Let's have some steak," right? And it'll come out something else, like it was kind of reading my mind, knowing that my wife would reject it, and it said, "No, let's have some soup." You know? like it mistyped on purpose almost. But that's a huge area, that voice recognition, because a lot of people are forgetting how to type. And you know what? If your only computing device is a phone, you never really learn how to type. Did you guys have keyboarding classes in school?
Yeah.
Right?
Pain in the butt.
All right. I did too, but you know what? How I learned the first time on keyboard? It was a mechanical typewriter, like the arms would move, right? And you get to the end of the line, it would go ding, and you'd have to grab the thing and go like
You got
this.
your face ripping on the ink right now.
Oh man, yeah. But I took many keyboarding classes, like junior high school, you know, etc. And I can type pretty fast when I get into a zone, right? And I'm going to tell you what, it's still an important skill, but what I see happening in the future is people aren't really going to worry about typing. It's all going to be voice recognition.
We're actually not teaching cursive either.
That disturbs me a little bit.
One cursive, you don't-
I hate cursive, honestly, but it disturbs me a little bit that, you know, I look at like my daughter, right, and she like, honey, you should work on your handwriting. She says, Dad, it doesn't matter. We just type everything up anyhow. I'm like, all right, burned. You know, my daughter just burned me. You know.
I was about to say, also on top of that, everybody's writing short words. So, like I said, spelling out the words, you just put the acronym.
Right.
Laugh out loud, LOL.
Right. Well, that one we know.
Yeah, but it's gonna keep going, and I'm like, there's new stuff, and my son hits me up with some of this stuff. I'm like, what in the world is that?
You know, get with the program, Dad.
And,
Right. Well, yeah, that happens quite a bit, but I'm a weirdo because, like, when I send an email or a text, I, like, fix my grammar and drop commas in, and I say hi and bye and, like, sign my name at the bottom. Not always, but, you know, if it's, like, important, I actually take the time to make sure that it's right before I send it. Actually, if it's really important, I'm not going to be texting, honestly. I'm still going to pick up the phone and talk to somebody or write them a proper email. Yeah, so I think it's kind of interesting because there's been some really interesting things happening on Facebook the last week. And my wife kind of fell into it. In-laws.
I'm getting phone calls.
It's my in-laws, so.
Lisa's gonna ask you about a back brace. I just had a stupid robocall about that.
Well, you know, the point is, folks, that, you know, how you choose to communicate really kind of impacts that. But I think in terms of, like, the input devices, it's kind of interesting. Have you guys ever played with any of these devices? Or ever hear of any of them, right?
Yeah.
Right, you got the Wii at home, you put the sensor on the TV and you move the thing around and it kind of follows you. Or, you know, the Xbox has got the Kinect thing where you can just use your body. You guys, you know, use some of these things. But that Wii motion controller is kind of a weird one. And the strange thing is like nobody knows what they are, right? But I actually have one on my old laptop here. And it's this like weird little sensor that shoots 2 infrared beams up. You can't see them. And you just hold your hand over it and move your hand around, and point and click, or grab and twist, or pinch and zoom. And you're not doing it on the screen, you're doing it in midair. I'm going to tell you what, it totally sucks. There's a couple games where it works kind of okay, but I never really got the feel for it. And I bought the laptop because I'm like, wow, that's really cool. And I don't even use it. And then I upgraded to Windows 10 and the drivers don't work. Right, that's kind of how it goes. But it is out there and it's kind of an interesting device. Here's things that we might not even think about as input devices, though. All right, well, let's talk about the middle bullet, point of sale terminals. My student Jason, right? The name of it, the company you work for, POSIQ. That's all about point of sale. Restaurant, money systems. That's like their thing. So, yeah, that's an input device. Because you walk up, scan your product, point of sale system, scans the barcode, goes into a computer screen somewhere, computer memory. So that's an input device. ATMs, yeah, you can put your money in there. Hopefully you get some out. What's a magnetic strip reader?
Like your credit card?
Got it. And what's the big scam these days? Yeah. People put skimmers on ATMs and point of sale systems. Happened to me about a year ago. I don't know where I was or what I did, but I used my debit card, and that's even scarier, right? Not a credit card, debit card. Grabbed my card information, they made a duplicate card, and started chopping. And fortunately, I use educators, right? They saw like, hey, did you just spend $400 at, Dollar Tree? I'm like, I really don't shop at Dollar Tree, especially not out in Madison. Right? And so they like caught it, sent me a message, a text and an email, right? And I'm like, no, that's not me. And they gave me the money right back. Do you know how many people got burned like that and still get burned? Yeah, a lot of people, so be careful. And the other thing that's really kind of fascinating is a lot of our cards these days and even our phones have RFID chips in them. And people can use scanners to intercept the information directly from your cards, and then take that information and do whatever they.
You gotta be very close though, right?
Yeah, yeah. It's NFC,
Yeah,
right?
It's like right there.
So like when you walk up and you do like the pay with your phone thing, or you might be a little too close to somebody else's device.
But they put like one of those things you put on the ATMs almost. You like put your phone there, you wouldn't even know it's like that plastic piece taped on or glued on.
Yeah, and you don't know, and that's kind of the scary part of it. Now I know that a lot of paranoid IT guys, what they're doing is they get the metallic wallets, right? So people can't scan their cards. And they shut off location, NFC, Bluetooth, heck, Wi-Fi too. Nobody's going to find me wrong. Yeah, there's still RFID chips on your phone. Most of them are attached either to the chassis of the phone or wrapped around your battery. You are still completely trackable even if the power's off.
Do they come with burner phones too?
Absolutely, even worse on burner phones. But see, the burner phones, right? All the people that use burner phones for nefarious reasons, they just use them a couple times. Awesome. Right. That's kind of the problem with some of these technology. I know we're out of time here, folks, so we're done. We're going to continue our talk next week. Okay, so I'm not doing any lecturing on Chapter 2, but you do have a couple of homework assignments to do in there, so make sure you pay attention to those. Another article next week based on what we're doing in Chapter 3. We're also going to continue the hardware stuff next week, so I want you to have a little bit handle on that. When we get done with Chapter 3, we're going to have a quiz. I'm going to give you guys fair warning. All right. Have a good week, you guys.
So you are getting an assignment?
I am. The hardware? Yeah.